Today's webinar is the best practices in molecular filtration for HVAC applications. I'm going to introduce the Education and Training Committee Chair, Matt Brooks, in a second, who will welcome Paula here in a second. But just give us a second. Let's actually let you know what else is going on with NAFA. The NAFA is the National Air Filtration Association. If you made it here somehow by accident, we want to let you know we have a couple conferences every year. Earlier this year, we were in the Dallas area for our technical seminar. That'll be in next spring again. We'll be coming up in Tempe. This fall, we will be in Maui. This is a great place for if you're a manufacturer or business owner or executive and you want to talk more about not necessarily just technical applications and technical air filtration content, but another place to also talk about the air filtration business. And of course, bring your spouse and or bring your partner along. So take a look at that. It's coming up very quickly in just a couple of weeks. So aloha. There's the technical seminar will be at the Omni Hotel at ASU, a really cool location there in Tempe. Fly into Phoenix there, April 2nd and 3rd. For that is some highly technical content. That's where you should bring, your sales folks. That is where you're going to bring your engineers. Very, very dense content when it comes to air filtration. We usually have a lot of research shared there. So if you want to learn more, if you don't know it all, we don't know it all either, right? So come to the tech seminar and put that on your calendar. This is the best practices guidelines. Today we're covering the molecular filtration guidelines. And so kind of in short is the guidelines are the practical way to apply a standard, right? So ASHRAE has standards, but ASHRAE standards, for lack of a better term, is they're talking about particles and they're talking about microns, right? But what does that mean to a building owner? That's what the guidelines are. They're going to apply these standards in a way that is on the ground, so to speak. So you can download these. These are free. You can go to our website, go to nafahq.org. And then finally, if you are customer facing, for instance, if you're an air filter distributor, you might want to associate yourself with the air filtration guidelines from NAFA. You can actually brand them. So we can help you do that. And then it's a great leave behind if you go to a customer and leave this behind versus just leaving your card, leave behind some education as well. And then finally, we do put out a ton of content. We have a very active LinkedIn and YouTube and other social media channels. And then also we have a podcast. So take a look at that wherever you want to consume air filtration content and discussions. We should be there. All right. So let me hand it over to Matt Brooks. Matt Brooks is the Education and Training Committee Chair for NAFA. Thanks, Matt, for volunteering. Thank you, Paula, as well. I'm going to hand it over to you and get started. Thanks so much.
Awesome. Thanks, Tony. Thank you, everyone, for joining us. I'm very excited for today's webinar. Today, we have Paula from LMF Services. She is the lead author from our Filtration for Molecular Filtration Best Practice Guidelines. And that's a general overview of how to best apply this topic, molecular filtration, in HVAC applications where you need to remove gases, airborne contaminants that might already exist. And in today's webinar, in an effort to support our Education and Training Committee's mission to expand the knowledge and promote the importance of air filtration among NAFA members and end users, Paula is bringing us some really good information. She has been in the molecular filtration industry for over 40 years. She's a wealth of knowledge, and she's deeply involved with ASHRAE. She's the former chair of TC 2.3, which is the gas contaminants. She's currently a voting member there, and as well as she's involved with ASHRAE SPC 145, which is the gas phase testing standard. She's also a life member of ASHRAE and a voting member there. So without further ado, and to give you as much time as we can to dive into this technical topic, Paula, I will hand it over to you.
Okay, whenever we're ready, Tony, we can start. Okay, today's agenda. First of all, I'll tell you that there's no way that I can give molecular filtration in 30 minutes. So this is really some guidelines to help you if you have a situation where you need it. These guidelines that I'm giving you are going to give you at least the questions you should be asking and the information you should be providing to whoever you're going to so that they can give you the best possible solution for your problem. So we're going to talk just briefly on removal methods, and then we're going to go into some design parameters. And those are critical in order to give you an effective filtration. Then we're going to talk about applications. Where are they used? What are the more common ones? What are the easy ones? What are some of the unusual ones? And then from there, we will go into questions, any ones you might have. So we'll move on to removal methods. Adsorption. You can read it. The process by where one substance is held onto the surface of another. It's generally associated with activated carbon. And it's a surface effect. Have you ever taken a balloon and kind of rubbed it on your head and sound it stick to the walls? That's van der Waals forces, and that's exactly how chemicals are attracted to activated carbon. There's a little force there where it attaches to the surface of the carbon, and in fact, it doesn't stay on the surface. It then goes into the pore structure where it becomes liquid again. High temperatures, in the case of activated carbon, can cause desorption. Well, why? Because it goes in there as a liquid. If you put high temperatures with it, it sends it back as a gas, and it may end up desorbing. Humidity can have an adverse effect. Why? Because carbon loves water. So if you put humid air through a carbon bed, it will pick up the water, and it will reduce your capacity. A general good rule of thumb, and molecular weights and boiling points are pretty easy to find if you know your contaminant. A molecular weight, a compound greater than 50 and a boiling point over 120, those are usually picked up pretty well by activated carbon. So the next method on the next slide we'll see is a few of the examples. Things like toluene, methyl ethyl ketone, you may not recognize them, but they are out there. Cyclohexane, methylene chloride. There are a few different types of carbon. Coconut shell being the most common, literally comes from coconuts. These coconut shells are burnt, buried in the ground for months on end, and then taken through an activation process. In most cases, you can't tell the difference between a coal and a coconut, but there are some compounds where it's important. Methyl methacrylate, that horrible smell if you ever walk by a nail salon, that's methyl methacrylate. It cannot be picked up by a coal-based carbon. It has to have a coconut shell carbon, and that has to do with the pore structure. Nerve gases and mustard gases, the old chemical compounds used in World War I, those are all picked up with a coconut shell carbon. Depending on the compound, and it is different, and the concentration, it can absorb up to 33% of its own weight. So that's some of the things. If we continue on, next slide. The next one would be chemisorption. So for those things that activated carbon can't pick up, there's a method called chemisorption, which is the result of a chemical reaction. Once again, on and in the surface of the adsorbent. It is irreversible. It is essentially instantaneous. High temperatures may increase that reaction rate in chemisorption, and humidity is actually favorable. Matter of fact, if you are buying a product that has, whether it be a chemically treated carbon, which we'll talk about later, or a permanganate product, water is already added to that product because without water, that chemical reaction cannot take place. So on the next slide, this is what some permanganate media will take out. It's a broad-based oxidizer, means it's not picky. It's going to pick up sulfur dioxide. It's going to pick up formaldehyde. It's going to pick up hydrogen sulfide and nitric oxide. Once again, cannot be regenerated. One of the major differences between the activated carbon media and the permanganate media is activated carbon can be regenerated. And we do live in a world where we try to recycle. So when you can use activated carbon, It's good because most of the time, if you have enough of it, it can be recycled. If you use a blended media, it can't be, it has to be disposed of. If you can separate the two because you need both, it's always to your advantage. On the next page, we'll see some of the other types of impregnated carbons because permanganate still doesn't do it all. So you got what we call base impregnated carbons, and they will remove, as you can see, some of the same things that the potassium permanganate removes, except that they are much more specific. So while potassium permanganate will also remove some of your VOCs, your acetones, and your MEK, these carbons will not do that. They will literally pick up just what they've been impregnated for. And then we have our acid impregnated carbon, and this is pretty much the only product that'll work very well on ammonia and amines. And I'm sure that there's few of you out there who've always seen the term and heard the word zeolite, and it was made famous many, many years ago by Honeywell. Zeolite works great in water. It does not work on ammonia in air. It has about a 2% capacity. But it was a great selling tool, and they did a great job. But unfortunately, that myth has continued on. But if you have high level in ammonia and amines, you cannot use a zeolite to remove it. And on the next slide, there are specialty carbons because there are other things out there. Mercury removal. And you might say, well, where is that? Well, a lot of the dentist office have a need for it. But one of the big thing is in your lights. When you're trying to destroy your overhead lights in a plant and whatnot, a lot of those have mercury in them. So there are actually companies that take those, they recycle those lights, and they have to use a certain kind of sulfur impregnated carbon to get rid of mercury. It's also found in the soil if people are digging up soil. Very, very common in the mining industry. And then we have nuclear grade carbons, and that is exactly as you imagine. It's for nuclear plants. And those are specialty impregnated carbons. Maybe some that you won't use, but should a facility trying to destroy lights come to you, you can tell them, no, you can't do that because that's regulated, and mercury is heavily regulated. And on the next slide, design parameters. These are the real critical ones if you want your filter to work. And we're going to go into these in a little more detail, but obviously we'd like to know the contaminant, because if we know the contaminant, it aids in our media selection. We need to know the air volume and the velocity at which it's going through the filter, and that will aid in our filter selection. Temperature and humidity, once again, most of these are never recommended over 120 degrees F. So if you have a system that's running at 200 degrees, it's hot, don't bother putting a filter in, either a chemically treated one or a carbon filter. You have to bring cool air in. Pressure drop. We need to know what kind of pressure drop your system can handle. The removal efficiency required, and I say required and requested. In some cases, there is a requirement. If you're doing paint spray booths, or somebody says, hey, I have to get rid of 90% of this, that's the requirement. In some cases, this is just a nuisance. This is a truck, a diesel truck idling in the back of a building where your air intakes are, and it's sending all those wonderful smells in for about 20 minutes. And they're just trying to reduce that odor for a while. And then capacity. And that capacity totally depends on your change out cycle. You don't want to sell someone something that's going to last 4 years. And by the same token, you don't want to sell them something that has to be changed every month. So the reason we need all these things is so that we can kind of give that client the desired time frame. And cost, obviously, is always an issue. And I'm sure you're all well aware of that. And then ease of maintenance. Some of these filters are heavy, and they're awkward, and they're big. And you don't want somebody carrying a 72-pound filter and having to walk up, 10 flights of stairs. So maybe instead of a full size, you go with a half size. Your maintenance people will love you for it if you take them, if you consider them. I've actually seen jobs ship overseas and filters go only to find out that the door to the system had a pole in the way. And when they opened it, they couldn't open it all the way, and they couldn't get the filters in, and they had to do all sorts of work to do it. So ease of maintenance, make it easy on your maintenance guy, because then they'll come back and want you to do it again. We'll go on a little further. Contaminants. Well, these are often unknown in most applications. There are a few where we know them, and we'll talk more about applications later, but you often don't know the concentration. You often don't know what's out there, but there are application guides. Many places offer them. They might tell you this is what's found in a nail salon. In fact, the molecular filtration guideline does give you some of those. These are the kind of contaminants you might see in an application. What do you see in a building? What are you getting from outside air? I mean, the EPA, you know what's in your outside air because the EPA has stations all over the country, and you can actually look and see the level of contamination at any point in time in any major city. So you know what you're trying to remove if you're trying to clear outside air. Okay, air volume and velocity. Okay. Well, obviously we need to know the air volume because we need to know how many filters. And in most cases, the manufacturers, because particulate filtration has been around a whole lot longer, the manufacturers have made their products to go along with particulate filtration. So if you have, don't exceed 500 feet a minute, in most cases, you will have a carbon filter that will work at 500 feet a minute, provided it has the right depth. And the velocity through it, well, that's beyond critical, because if you run it too fast, it will not pick up. Temperature and humidity, again, some media not as effective at high temp. Some can be adversely affected by humidity. These might be some of the things you want to know in case maybe you want to blend the media. In most commercial applications, if your system is running and you're putting air through it constantly, humidity isn't a major issue unless you're, living someplace like Florida or where real high humidity can last for a long period of time. And on the next slide, we'll go a little. This is how your systems are designed. Most systems have been designed to give you a 0.07 second residence time. And I'll explain why it's not applicable in impregnated technologies. This is for a bulk system. And that doesn't mean that you're going to get 100% efficiency. It just means that you're going to let 100% of the air actually touch the filter media. It doesn't relate to efficiency, but if you don't at least have that time, it doesn't have a chance to capture it. It doesn't work that way in impregnated technologies because they actually use fine powder. And as I explained with activated carbon, it's a surface phenomenon. So the more surface you expose, the faster a contaminant can be picked up. But don't confuse that with capacity, because a pound of powder and a pound of granular can pick up the exact same amount. So the powder will pick it up a lot faster than the granular will, but it will not last any longer. And there are benefits to both technologies, provided they're used correctly. Pressure drop of bulk media beds, they don't increase, provided they're protected. I say this often, and a lot of times people come back and say, well, the pressure drop went up. Well, if you don't put a particulate filter in front of your carbon bed, and there's a lot of dust that gets on the carbon in front of this tray or on this filter, your pressure drop will increase, but not because the carbon is being loaded. It's because you're blocking the panel. And it can become a very effective filter if you let it build a ton of dust on it. But it gets to be a very expensive particulate filter. The pressure drop of combination filters, those that are using pleated media, those do increase the same way a particulate filter would increase. Important to note, the best time, the most effective a carbon media is, or any kind of chemical media, is when it's first put in the system. It starts out high, and its system efficiency decreases with time. It's the exact opposite of a particulate filter. When they load, they can continue to load. As a carbon filter loads, it loses its ability to load because it loses its pore spaces. So that is that's a key to note. Make sure they're protected from dust. And on the next slide, we'll talk about some applications, which I think you're probably pretty well aware of them. Corrosion control. I divide them into three markets: preservation and air quality. And that air quality can be both indoor and outdoor, what you're putting outside into your space, in the case of, like, say, a restaurant. So let's go on and let's talk a little bit about the corrosion control market on the next slide. And what was it for? Well, this was actually one of the first things that media was used for. Protection of electronic computer equipment and pulp and paper mills and refineries. When they all went to computers, they found out that all the contaminants in these refineries, like hydrogen sulfide and oxides of sulfur and ammonia and ozone, they found that those things turn into acid gases and they ate the computer boards. So the computers were failing. So there's actually a standard out there, which I don't have, but I mean, it's readily available, and if anybody's interested in it, that in order for you to up any of these pulp and paper mills and refineries that are run by computers, where they have computer technology, they have to put in gas phase filtration to meet a certain air classification, or you have lost your warranty on your computer. So that was the first big push, because at some point in time, somebody said, geez, I spent 10 grand on my computer equipment. It's down in less than 6 months. And now they won't warranty it because my air isn't clean enough. So that was one of the big issues. Most of those will use either an impregnated carbon or a permanganate media. And you can see that from the acid gases that are in the air, or the chlorine. In the case of ozone, however, all you need is carbon. Straight carbon will remove ozone. And as I told you earlier, ammonia, you need an impregnated media to remove ammonia if you have any kind of high level. On the next one, we'll talk a little more the preservation market. And this is something you may see a little more often. Museums, archives, libraries, almost every major museum and archive, and even many of the major libraries have gas phase filtration in them. And that is for preservation, because if the acid gases get in, if you've ever been to a library and they have an old book and you pull a book off the shelf and you see the yellow on the outside of the pages, that yellow is the destruction of that paper from acid gases. So needless to say, things like the Baseball Hall of Fame, and I mean, you name it, the museums, they all put in filtration. These are some of the major contaminants. My recommendation on this is we have a guideline on museum archives and libraries, and it really delves into molecular filtration. So if that's one of your applications, it is a really helpful guideline to lend you in the right direction, because the fact of the matter is there is no known good level of contamination in a museum, archive, or library to protect some of these artifacts. The last market on the next slide is our air quality market. Well, this is the fun market, in my opinion, because you don't always know what you're dealing with, but it's also the most difficult one in many cases. In the case of air quality indoor sources, well, we've got building equipment, we've got office equipment, all of your laser printers and whatnot, they put off ozone. That sweet smell, if you stand there and make a lot of copies, that's actually ozone. You really shouldn't stand there and smell it. In fact, ozone is the only contaminant that's regulated both indoor and outdoor. Furnishings, your carpets, your draperies, all of these things that come new, they might off-gas formaldehyde. They will all off-gas when they're new. Occupants and the trend to put a restaurant inside buildings. And while sometimes that smooth food smells really well, those restaurants have to exhaust to the outside air. And oftentimes that smell is not so good and gets re-entrained into the building. So there are many things. So I've listed contaminants here. These aren't even close to the number, but formaldehyde, toluene, ozone, ammonia. I mean, think of the cleaning compounds that you might use. there are a lot of indoor contaminants. And when we years ago decided to close up our building, it became more and more obvious. They are beginning to make building materials that don't off gas, but that's few and far between. The next air quality market we talk about is the outdoor sources, because obviously you bring those in. Well, it's vehicular exhaust. Maybe you're located downwind of a refinery, or maybe you're located downwind of a wastewater treatment plant. Maybe you're near a manufacturing facility that even though they may put filters in, there still is an odor that comes. Agriculture, you oftentimes have a lot of contaminants associated with agriculture, the spraying of spraying crops, chemical plants. So now, not only do you have indoor contaminants that you're bringing in, but now you're bringing in your outside air, mandated, and so now you're bringing in ozone and sulfur dioxide and chlorine and all sorts of VOCs from whatever might be in your building. So it's really critical. But one of the things I would have you take note of is that if you see the contaminants, you see that these are often repeated. So we're oftentimes dealing with a lot of the same contaminants. The next slide. We'll talk a little bit about conclusions. So first of all, let's review your contaminants. You've got application guidelines. They're listed. They'll tell you, what do you have if you're near this? What do you need if you're near that? That information is available. You can find it on the Guide to Molecular Filtration, but you can also find it in depth in NAFA's books. The critical nature of the contaminant. Are you dealing with a nerve agent where a small amount will actually kill you? Or are you dealing with a diesel truck or a bus that's idling outside for 20 minutes? So you need to understand how critical it is, so that way you can understand the efficiency level you need out of your filter. You need to determine some possible media selections. Most of your time, your manufacturers can help you with that. Talk to a CAFS at NAFA. They have guidelines. Many of them have some experience, and they can help you pick out the right media. Then you select a filter a type. And there are many out there, as you well know, anywhere from 3/8 inch to 24-inch deep bulk housings. So you want efficiency versus breakthrough. Might be a little hard to understand, but as I told you, that a carbon filter is best when it's first put in. So you may start at 90% efficiency on a bulk filter, and it may drop to like 60, but it may stay at 60% for months. The question is that good enough? And it may well be. And in many commercial applications, that's all you need. However, if in fact they want something that removes all of it quickly and it doesn't last very long, then in that case, you might be looking for some of the pleated technologies where it picks up a lot, but doesn't last long. But maybe they don't need it to last long. So you've got to give your end user some selections, and you got to take into cost considerations, because you have to keep, you may make that first sale. And if the first sale you sell them is $30,000 and it lasts for 4 years, they're not going to be happy. But if you sell them, 10,000 and they change it in a month, they won't be happy either. So you really have to keep in mind what's going to happen the next stage down. This is some of the information that's necessary. It is a proven technology. There are tests out there. 90% of the time when I get a call in my consulting business if something hasn't worked, it's not because the filter didn't work, it's that has been misapplied. And that happens very frequently. And the whole reason for our molecular filtration guidelines was to help people not misapply their filters. Understand that if you're in a research application with small amounts of contaminants and you just need to kind of keep people happy, then you don't need a big bulk filter. But if you're in an airport and you're trying to keep all the outside airline exhaust from your panels, you may need a bulk filter system. So the key is knowing what your end user wants, trying to do what's best for them, and not misapplying your filter and your media. And that's kind of it in a nutshell. Anybody have any questions?
Well, there are a lot of questions. So
That's fine.
thank you so much for getting us started down this path. We had a couple questions that came through around diesel fumes when you were mentioning that, and
Sure.
it revolves around what's the best thing to use. Is it straight coconut shell carbon, or is there
It's a
something better?
blend. It's a blend. It's a blend, and keep in mind that diesel fuels are also loaded with particulates. So if you have a diesel fume problem, make sure you got a real good particulate filter in front of it.
Multi-stage filtration, and some of the best.
That is.
There were some questions about how to measure this. So, is there a device similar to like a particle counter that someone can use to get an idea of what's going on?
There are a lot of devices on the market. The problem, and it's not a problem with the device. The problem with it depends on your application. So if you're just in a commercial building, even though there may be smells and contaminants, you may not have a device that is sensitive enough to pick up what's there. But there are VOC monitors. I personally don't sell them, but they're out there. And there are some good ones, but you don't always get what you need from them because the levels in commercial buildings are not always, unless you have an issue, are not always health issues, and the levels are not always high enough to be measured. However, if you're dealing with paint spray booths and whatnot, yeah, there certainly are. There's a lot of monitors out there. They're not quite as easy as a particulate filter. I mean, you can walk in with small ones and sit in a room and get it. But that's a technology that's improving. In fact, it's a research project that has been put on TC 2.3's plate for a while. Let's research VOC monitors to see exactly what they can do.
Wow. So there's some options and more to come in the near future, it sounds like, with ASHRAE's getting more involved in it.
Yes.
There were some questions about how these molecules are being trapped or destroyed, and how that could tie in with a virus or bacteria or something along those lines. Can you kind of explain that a little bit better for everyone?
Sure. Well, okay. They have nothing similar to a virus or a bacteria. And you don't actually kill viruses either. You can only inactivate them because they're not alive. Only because that's part of my background. But in carbon, the molecule is trapped inside the pores. So it literally creeps down into these pores and it becomes a little liquid again, and it stays in there. With chemisorbents, it's a chemical reaction. So in most cases, what's happening is you're taking the sulfur dioxide and water and the caustic that is put on it, potassium hydroxide, and you're turning it into CO2 and water, and that's what comes out. So you're not introducing more chemicals in. So in that case, the contaminant is not so much destroyed, it's changed. It's changed, and what sits on the carbon is actually a salt. So that's what happens. And when the carbon comes back, sometimes if you have enough, it actually looks, instead of black, it almost looks a pale white or gray from the salt that sits on there. So usually in those reactions, that's what's happening. It's a CO2 and water that is released. But with activated carbon, it's not released. If you heat it up, and I don't mean in your oven, if you reheat it to about 1500 and 1600 degrees, then you can burn off these volatiles. So in activated carbon, they are not changed. I don't know if that answered the question.
Yeah, I think it did. I wanted to add the virus piece to it because there was a couple of questions involving there that you cleared up for everybody.
Yeah.
There's a question about specifically about CO2 and how molecular filtration can help with reduce indoor CO2.
It can't. Oh, okay. It can't in indoor air here. Obviously, there are products that remove CO2. They are operated at zero humidity and a real exact temperature. One of the products is called Hopcolite, if you want to look at it. It is what they use things like submarine, because obviously they have to get rid of CO2. It is not, you are not able to use it in a commercial market because you can't control the conditions. The conditions have to be perfectly controlled in order to do it. So if you want to get rid of CO2, bring in some fresh air.
What about carbon monoxide?
Same thing, bring in some fresh air. And there are, I mean, there are things like, now we're going to get into detail. There are things like swing systems. So like, years ago, you would have two big carbon tanks. And I'm talking tanks with, 400 or 500 pounds of carbon in them. And so you would run the CO2 through the carbon. It would hold on to it for a minute, and then you could turn and release it elsewhere. But it's not a practical solution, and certainly not one you're going to ever bring into the commercial market. The solution for that really is bring in fresh air, as fresh as you can get it. And if it's not fresh, put a filter in to get it fresh. But you have to move the air to get rid of the CO and CO2.
Awesome. There are some questions about where or who they should be contacting if they think they need, if someone thinks they might need molecular filtration added to their facility. Is there a special place to go? I think I have a good answer for this one, but I'll let you answer it.
Well, is there a special place to go? I don't know. I mean, I guess that you could contact some of your local air filter companies. This is a hard one for me to answer. I mean, I'll answer any question you ever want, but you can always contact NAFA, and they can put you in touch with a local NAFA company.
Love
And
that.
that local NAFA company may, if they don't have experience, may send you to someone that does have experience in it, or they know someone that they can send it to. Just be careful. I would not contact an engineering firm, no offense, but they have not come up on this yet. And that's to the detriment of those of us in the industry. We didn't teach them well enough. That's not a downing to them. It's to us who didn't educate them. I've seen specs that call for carbon that has a 25 CTC, and in my book, that's spent. So I could sell them spent carbon. I mean, so it really is. And there are a lot of people out there. There are a lot of smoke and mirrors still. I see a lot of things out there. Like there's a special carbon from Egypt that works great on marijuana. There is no special carbon from Egypt that works great on marijuana. So you have to be careful. So I would tell you to contact NAFA, let them send you to your local representative. These people have been through things, and if they don't have the answer, I think they'll come and find it for you.
Fantastic. I would agree with that. I think that's a good place to start, at least.
Yeah.
There's a lot more questions kind of going into very specific applications, which we will have to come back for another time for. But before we wrap up, is there anything we could be looking forward to coming out from ASHRAE with some of the stuff that you're deeply involved with?
Yeah. There, ASHRAE is putting a new standard together. In fact, I think it's there's 145.1, which is testing for just bulk media. There's 145.2, which is testing for filters. And now there's 145.3, which is testing for ionization devices and other things that claim to remove VOCs. That is in the process, and I believe it's almost ready for public review. So there will be some new test standards coming out. In addition, ASHRAE puts out position papers. And it states their position on various things. So we just finished writing one on HVAC, filtration and health and HVAC, and that should be coming out. We finished writing it. We finally got approval from the ASHRAE Board of Directors to publish it. So you can find that on the ASHRAE website. So that gives you insights into what ASHRAE thinks you should be doing for filtration. And this is for both particulate and gas phase. It goes through it all. And there's another position paper, but that one's not quite done yet, that we have been working on. And there's usually about 6 people that work on this, on these position papers, but then they go through more committees than you can imagine, and then they go through the ASHRAE Board of Directors. And so, so there are some documents there that will help. And I think that's what you'll see new, some new test standards for some other new methods that have come out to remove contaminants, and then some position papers that will help you understand where ASHRAE thinks things are going.
Fantastic. Awesome. So I think that's actually a lot to look forward to. That's all we're going to do for today. I believe we are going to be posting the, actually, I'll hand it back to Tony in a minute here and let him kind of give the wrap up. But Paula, thank you so much for the time on it. We appreciate your expertise and all you do with NAFA.
My pleasure.
Oh, Tony, you're muted on that one.
Yeah.
There we go. Thank you. Geez, it's almost stemmed like I haven't done one of these before, right? Okay, so thanks so much, Paula. Even as a layperson who knows nothing about air filtration, except for the fact I should change my filters, right? If you know nothing, that's one thing you should know. I learned that. But thanks so much. That was very informative. Thanks, Matt, as always, for great engaging questions and handling all of that. We will and always do record our webinars, so this should be available on our website here in a day or two. It'll be actually, if you subscribe to YouTube, our YouTube channel, you'll get notified right away once we publish that. So that's a little shortcut, little secret backdoor for you. And then I believe, Paula, we're able to share your slides as well. Is that okay?
Absolutely.
Okay.
Yeah, absolutely.
Perfect. Those will be available from our website as well. You can download that. And then everybody who's subscribed, or excuse me, everybody who registered today will get an email with a link to the best practices and guidelines page. There you can download any of those, especially the molecular filtration, our favorite today. And then also get a copy of the recording and a link to the PowerPoint as well. And then, of course, soon I'll put this up on our podcast page. So even if you didn't get to follow along the slides, as you're driving to your next client, you can listen to Paula talk about molecular filtration for another round. All right. Thanks so much. Thanks for listening and watching. And we will see you on the next one. And the next webinar we're looking for will be in November. So keep your eyes peeled on your mailing list. Thanks so much. Take care, everybody.
Thanks, everyone.
Thank you.